Good morning, everybody. Welcome to this ArcelorMittal digital breakfast, the first one for us to hold today on the seminar on steel in urban environment. I hope you can all hear and see me clearly. Likewise, I hope that all participants joining this morning from somewhere at a European location did receive their breakfast box on time, so that you can have your morning cake and coffee while listening. We're doing the same here. My name is Arne Langner from ArcelorMittal Communications, and we are providing this morning session to you with our colleagues who are experts in steel products for construction purposes. Today we aim to focus one day ahead of the Expo Real trade fair in Munich on advantages that steel has on investment decisions when you are, for example, planning a high-rise building in an urban environment together with an underground car park. Questions we want to give answers to today are: what will high-rise buildings need in future? How can you create additional space in dense urban environments for housing or office purposes? How can you fulfill flexible office requirements when thinking of office sizes, walls, for example? And last but not least, how can you create additional value by building in a sustainable way? That means saving CO2, reduce energy costs, energy needs, but enhance flexibility at the same time. We're convinced that steel offers all these answers, being, as we call it, the intelligent construction choice of fast, flexible, and sustainable real estate needs in the post-COVID-19 time. Yes, COVID-19 already changes the way we live and work, but maybe it will also change we construct buildings in future. A few housekeeping rules, and then we can start straight away. During the conference, all participants will be muted and only the presenters will speak. Certainly, you can put your questions in the meantime while they speak by using the Q&A button at the bottom of your screen. You can simply type in the questions there. I will then read it out loud after each presentation so that the speaker has a chance to answer. Finally, we are recording this webinar and will make it available later. Same is valid for the presentations, which you will see in the next 60 minutes. We will distribute them via email to all of you. And now I would say floor open to our introductory session with Olivier Vassart, CEO for ArcelorMittal Steligence. Olivier, the floor is yours.
Thank you, Lars, for this introduction. So good morning to everyone which is connected. So to start this seminar, I want you to really take a step back. So you are sit in your living room, in your kitchen, in your house, in your offices, and I want you to look around you. And if you do that, you will see that you see approximately steel everywhere. So I have not, yeah. So if we look around us, we see that steel has been part of our history since ever. So since the Iron Age, steel is linked to the development of humankind, and we can see steel everywhere. So in the construction, of course, but also in all our house appliance, in our cars, in our pens, in everything we can find steel. But steel is mostly used in construction. So approximately the half of the total worldwide steel production is finally ending into construction. So construction and steel is a major importance. And if we look in Europe, 60 million tons per year of steel is used in the construction sector. Next slide. So world is facing a really huge challenge. So we estimate that the world population will grow by until 9 billion people by 2015. Each day from today, 200,000 people are moving to cities. This is a really huge challenge for municipalities, for builders, to be able to afford this, to provide to all these people affordable houses, affordable infrastructure, affordable school, affordable place where they can work. Then if we look at another challenge that we face is the global CO2 emission. When we look by sectors of activity, we see that the buildings where we live, where we work, represent 44% of the global emission. So if we want to sustain this growth of building new meter square, we need dramatically to change our approach. It's not thinkable and not feasible to continue to build building as we build today. We will not find enough raw material. We will not be able to sustain the amount of waste we are generating when we build and demolish building. So new approaches are needed if we want to sustain our way of life. We need to build without overusing our natural resources. And we need to find a way to be able to reuse or recycle better the building material that we are now putting in our different buildings. So since now more than 5 years, we are thinking about a new way to tackle the construction market. Before, we were looking at the construction towards the eyes of our client or customer. So which are the people who are buying us the steel. It means not you, not the investor, not the building owner, the people who are buying us the material. So we decided to look at construction industry from another perspective, not from a material perspective anymore, but really from a building. And what we realize is that today buildings are really a living entity. It means that building needs to be adaptable. Buildings are interacting with the urban environment. Building must in the future be able to change their utility. It means moving from an office to a residential, from a residential to a co-living part, a co-working part. So we need to think differently or building to make them adaptable to the future needs. So on the base of this, we said, okay, we need to change the way, and we need to look at how we can tackle this. So to understand what we have done, we put ourselves in your shoes, in the shoes of the investors. And we said, okay, we will look how today, for most of the building, the market is organized. The first thing, we saw that from design stage, we have an organization in silos. It means we have one team which is working on the foundation of the building. They try to reach an optimum for the foundation. We have one team which is devoted to the structural stability of the building. We have one team which is devoted to the flooring system we find in the building. Then we have another team, again, which is in charge of the envelope of the building. And finally, we have a last team, which is taking care about all the fluids, the ventilation, the water piping into the system. So each of these teams try to find an optimum for his part. And then we pile these optimum one with the other. But in any mathematical system and barely in any system. The sum of optimum is never a global optimum. So if you want really to optimize your building, to find the best solution for your building, you must not think in subsystem. You must think to the entire building and sometimes invest more in one part to save twice and to have twice the benefit on another part. Then what means optimization? Depending on the stakeholder you talk to, the answer will be totally different. Building owner and investor often focused on the total cost of the building. If you talk to an engineer like me, an optimum is when I will optimize the amount of material, when I will optimize the weight. Some other stakeholder will look at the optimizing the environmental footprint. If you talk to a building owner or a building user, he will talk you about flexibility. For him, the optimum is when he can change easily the tenant, when he can refurbish really easily. Speed of construction is another KPI. So it was necessary for us to find a methodology that will reconcile, on one hand, the holistic view of the building, and on the other hand, all these KPIs, which are different and providing you a different answer for your building. Because the cheapest building will rarely be the building with the lowest environmental footprint, will not be the building that will be erected and constructed the fastest. So we needed to reconcile all this together into a methodology. So the first step of our approach was to do this, to create a scientifically driven peer review method that will allow us to compare a building A with a building B, taking into account all these criteria. And then we applied this on one office building. That was our first thing. And we could see that choosing the right steel solution for this given building can provide us 10 key benefits. I have no time today to enter into all of these benefits, but I will highlight some. The first one, and for me this one is barely reflecting everything. On the left, you have a building which is designed in prefabricated concrete element. So prefabricated concrete element allow to also accelerate the construction time by doing off-site construction. But if you look at the building on the left and the building on the right, which is a building which is made of composite construction, it means steel and concrete jointly acting together. These two buildings are different. So they have exactly the same amount of meters squared to be used. They have exactly the same free aid at each floor. But from an external part, the buildings are different. And what happens usually in your project, your architect or your designer is drawing the building on the left. And then you ask engineer to evaluate the potentiality to use steel. So what the engineer will do, he will design the structure on the right, but he will put it on the architecture on the left. And it means that you will totally sub-optimize the steel building. So when you will compare at the end of the day, the steel building with the concrete building, you will say, okay, steel is not better than concrete. But if you think you're building in steel from the beginning, you can do dramatic savings. Here, on this particular example, we saved 11% on the cost of the facade, the cores, the stability of the building. This is a dramatic saving that you can afford only if you think your building first and from the beginning in steel. Second part is the speed. So even here we compare steel with prefab concrete, so not cast in place concrete. We can build the structure twice faster with the steel solution. So this, first of all, brings you a quicker return on investment because your building is finished fast earlier. And it's also decreased the construction cost because construction time is reduced, and you know all that a job site have huge fixed cost, and all these fixed costs can be reduced by the increase of the speed. And finally, if we go on the total cost of ownership for you, we can have an economic benefit of at least 15% compared to the alternative. But this, once again, when the building is taught in steel from the beginning on, where you can capture the advantages and the value of steel from the beginning. So having this in hand, these different findings, these different tools, we said that, okay, we need to change also ourselves, our approach of the construction market. Why? Because we were organized in silos, like the construction industry. So we had teams which were promoting the structure. We had teams which were promoting the floor. We had teams which were promoting the facade. Another team, the piping system. So we said we need to change this also within our company. And it's why we opened this branch, which is called Steligence, which in fact regroup all the solutions and all the product that ArcelorMittal can offer on the construction market. So this allows us to have a global approach of the building and also to help you in your project to find the best solution that can be offered. Because when you work in a product line, you will always, of course, push and try to demonstrate that the solution of your product line is the best solution for the project. When you have in hand a complete portfolio of product and solution, you can advise which one is the right one for the dedicated project. So the strategy has a little bit changed. So who decides if the building will be made with our solution? Is it our customer? No, it's you. It's the investors, the architect, the program manager, the engineering office, which decide if the building is tailor-made for concrete. The building will be done in concrete. If the building has been taught from the beginning in steel, taking into account the right grid, the right solution, it will be done in steel. But all these stakeholders, they are not interested in steel product. You are only interested into the final solution, which is the building. So we have put on the market in each of the European countries, we have put a network of engineers and architects which are supporting you in your different projects. So they are helping you at the early stage of the project to find what is the right technical solution and the best technical solution for your dedicated project following your KPIs, because a project is not another. So for each of the project, we have a right technical solution. So I thank you for your attention.
Thank you, Olivier. Now there is time to put questions. If you have any, don't hesitate. You can use the Q&A button at the bottom of your screen. And meanwhile, I have a question for you, Olivier. You were talking a lot about finding the best solutions, taking a holistic view on an office building, for example. And the question would be, what should investors focus upon when thinking about which material to use, and what would you recommend and why? Certainly steel, but why and not only? So please let us have your views.
Yeah, first of all, as an investor, you don't need to choose a material. What you need to choose is the specification of your building. Really often, investors and architects, they restrict themselves. It means when they start to think about the building, they say, okay, use the 6x8 grid as usual. We put pillars everywhere because we are convinced that will be the cheapest solution and the best solution. We always made like this. When you discuss with people and their answer is, yeah, we do this because we always made like this, it's not the right answer. So they need to dream more and to think more about what they want. So we can offer with composite construction, and once again, I don't speak about steel, I speak about composite, multi-material. So when we use the right material at the right place, we can really design and build efficient building. So if we look today, most of the building we destroy in our city center, we don't destroy them because they have problem, they have structural problem, they have stability problem. We destroy them because they don't correspond anymore to the needs of the market. So we need to think building in a different way, more flexible, building that we can easily adapt in the future. And there, steel can really be one of the key points, because steel is made by simple assembly of elements. They can allow really large free span without any pillar that allow the building to be easily refurbished, easily transformed. And for me, that's a key point if we want to sustain the amount of meter square we need to build and the amount of meter square that needs to be changed during the life of the building.
Thank you. We have one more question in the meantime, so I read it out. What's the percentage of steel usage in commercial buildings?
So I don't know exactly, I don't understand exactly the question, if it's the market share or something like this. The market share really depends on the region. If I take United Kingdom, for example, UK, about 80 to 85% of commercial buildings are realized in composite construction. If I take Germany, it's around 20 to 25. So it really depends on the area and on the construction habits. As I said, nearly everything is decided with the first drawing. So in UK, people are more used to use steel. So architects and investors are not at all afraid to draw building with 15-meter clear span. And when you do this, you see that your building is cheap and you don't have any pillars, but it starts from the first drawing.
Mm-hmm. Thanks for this one. I think that is how to answer it. That is different in each region and in each country, how much steel is used for commercial buildings, as you clearly pointed out. We have one more question even. What's the maximum grade of steel currently used in construction?
Yeah, it's really depend on the type of construction. If you take a building, a normal building, we use steel up to 500 MPa, mainly when we use it in composite with concrete. because using a composite construction will allow you to have a connection between the structure and the floor. So you have a more rigid construction, you have no problem of deflection, you have no problem of vibration. So it allows you to use higher steel grade, like 500 MPa. If you take bridge and really long bridge like viaduct and things like this, we go up to 690 MPa in the construction sector.
Okay, thank you, Olivier. These are all questions for the time being, so I think we can move on. And we come to Lars Pfeiffer. He's a CEO for ArcelorMittal Construction in Germany, Switzerland, and Austria. Lars, you will talk about us appealing modular construction and steel and what maybe commercial buildings can learn from the industrial side. So, Lars, the floor is yours.
Thank you, Arne. Good morning also from my side to everybody. Steel in urban construction, steel in the urban environment. Let me phrase it a little bit different, and Arne has already hinted that in his comments. In the next few minutes, I will tell you about the success of modular prefabricated construction in the industrial sector and what, from our point of view, the residential sector can learn from it and can take away from this. So let me start off by telling you about steel metal-faced facade systems, a product that has become widespread in the European industrial construction, a market of approximately 100 billion euros per year, with very high demands for robust and economic roof and wall claddings for the building envelope. Metal sandwich panels, as the most dominant segment in this product category, have conquered this market over the last decades with continuous and unbeaten success. Both market and capacities are growing steadily. Sandwich panels, you may know, consist typically of two pre-painted, so-called color-coated metal sheets that are covering an insulation core, and they are a good example on how the industrial sector changed from building craft, so actually handcrafting on the construction site, to an assembly process of a prefabricated product. With the core in this system not only providing the thermal insulation, but also transferring shear stresses and thus adding substantially to the stiffness and the load-bearing capacities of the product, we talk about an integrated system. Such products are fully airtight. They contribute significantly to the speed of construction, and last but not least, they are unbeaten in value for money. We consider sandwich panels as a first step of a prefabricated solution that allow large freedom in facade design, and that's concerning in particular color and geometry, but it goes as far as tactility of the product. And all of this is generated in a controlled industrial environment, producing millions of square meters in a very robust process. I'm trying, Pascal, to go to the next slide, but I'm not sure if that is working for me. If you can, yeah, thank you very much. Coil-coated steel provides fully finished surfaces in endless colors and shades, and at very reasonable prices. Processed in panels, it generates highly durable, mechanically strong, lightweight, and sustainable building products. This is available with many years of experience and established technical knowledge for both the planning process and also the execution on site. Service levels is generally very high and established supply chains can be capitalized. Let me give you some examples from projects that have been realized in the urban environment. Here you see a kindergarten in Vienna that is applying sandwich panels in different shades, right next, by the way, to one of the main roads entering the city. You can imagine the limitations in space that occur during the erection of such a project, and the benefit prefabricated systems bring in terms of logistics and erection speed. Such systems do not only work with new build, but also, or maybe even better, when it comes to refurbishment. This example here is a high-rise building in Paris, giving the whole structure a completely new and appealing appearance, being totally non-combustible when combined with the inorganic insulation material, as opposed to other solutions like thermal insulation systems that typically employ EPS together with plastic. Steel, by the way, as you know, a fully and endlessly recyclable product, is not only good for the building envelope, but in the form of lightweight composite flooring systems, ideal for the reconstruction of gutted historical buildings. Also, by the way, fulfilling very high demands in fire protection. Even very big monolithic structures like this car park in the city center of Leipzig, right next to the historic railway station, can mingle in pleasantly into the existing surroundings. So let me invite you to analyze the potential of modular prefabricated construction for your business. Let's investigate how to become more efficient and sustainable in urban construction. Let's continue, and that's probably the most difficult and most important point, to change the mentality in construction by inspiring smart ways of building, smart ways of constructing. Thank you.
Yeah, thank you, Lars, for this speech. And I would have a first question, if you allow, and meanwhile others can type in the Q&A section when you have any questions. And my first question is a bit beyond, but I would say, which role has a green building certification, like in Germany, DGNB or LEED or BREEAM, and how can steel help to support obtaining such a certification, and what would it mean for investors?
Yeah, we see, thank you, good question, Arne. We see that it's becoming more and more important also in Germany for the construction. I wouldn't say that Germany is really the forerunner in this, but we see the big investors, international investors, which are coming with high demands for the sustainability and looking at the environmental impact, not only of the construction, but also of the service life of the building. And lightweight construction in steel is performing particularly well in this. You can imagine, by building light, first of all, it automatically minimizes resources, and employing steel, as I said before, which is an endlessly recyclable product, it contributes to the sustainable footprint of the construction. I talked a little bit about the example of sandwich panels, which have been very successful in the industrial sector. They provide a completely airtight building envelope, which is a very important point when it comes to thermal optimization of the building. And they combine this airtightness with an uninterrupted full thermal insulation of the facade, and that is a very good and a very solid solution. Certificates, EPDs, environmental product declarations, are demanded more and more, in particular in Germany, and we provide all the certificates for all the products which are coming with it, may it be trapezoidal sheets, may it be sandwich panels. All of that documentation is available, and providing very good values for evaluation of a construction.
All right. Thanks, Lars. I don't see any further questions for the meantime. Okay, then I think we can move on. And thanks again for your time, Lars. And we would now come to the last presentation of this morning's session. It's with Joao Martins. He is a Senior Technical Manager at ArcelorMittal Sheetpiling Solutions. And he'll speak about how to optimize space and enhance sustainability. And we now go, so to say, below the soil when it comes to sheet piling solutions for permanent and also for temporary structures. Joao, the floor is yours.
Thank you, Lars. So for the next few minutes, I'll focus on underground car parks, as you said, and basements, and how to optimize the space using sustainable steel solutions. But before that, I would like to start with the definition of a sheet pile. Most of you have seen sheet piles, but you're not necessarily aware of it. So what is a sheet pile? It's in fact a hot-rolled corrugated sheet with a specific feature, and the specific feature is a Larsen type interlock, which allows us to thread the sheet piles together so that you can build a continuous wall. So a continuous wall usually for retaining walls, but sometimes it's also used simply to prevent pollutants to pass through this wall. And of course, the difficulty of such sheet piles is the rolling, because it's relatively complex to roll this type of interlocks. So what are the main type of applications? And I'll start with the maritime structures. I mean, sheet piles have been used for over 100 years in quay walls, breakwaters, jetties, so everything that's in contact with water, be it maritime or also inland structures. And then, of course, for permanent retaining walls. Here, as you see on one of the pictures, it's a bridge abutment, but also underground car parks and basements. They are used, I would say about 50% of the sheet piles are used also for temporary retaining walls. So if you want to build, for instance, a bridge pier in the middle of the water, you'd like to work in the dry, so you use a cofferdam, which is quite watertight, but also for excavation pits in urban areas. In this case, you would also use a retaining wall, and a temporary retaining wall in sheet piles is one of the options. Cut-off walls, as I said, to keep pollutants from passing through the wall, and then flood protection systems, like on the picture where you see a reinforcement of an old dike or a riverbank, so that it will be able to withstand the floods that will come in the future with a change in climate. So for maritime structures, the big advantage is that you have a prefabricated product that you can install directly into the water, for instance, like you see on this picture, so that you can be actually working, installing the sheet pile wall, but also backfilling at the same time concurrently, so that you can increase the speed of execution. And as the previous speakers have already told it, that's one of the big advantages of steel, it's the speed of execution. And afterwards, well, this is a container quay wall in container terminal in Poland. You see that it's like a 1 kilometer long wall, which will be there for the next 50 years and above. But in use temporary structures in urban areas, quite often architects and engineers are quite reluctant to use it, because they still believe that you cannot drive sheet piles in urban areas without a lot of noise and vibrations. So the old diesel hammers and all this stuff, they still exist, but nowadays there is pressing equipment, like you can see here near the central station of Amsterdam, a relatively high retaining wall that was installed close to the railway tracks, which are quite sensitive to settlement. So everything is feasible. The new technologies allow it, and not only for temporary, but also for permanent. A few pictures of underground car parks. So this is quite impressive. The building for the first, the Nachtal in Rotterdam, but below that we have 3 levels of underground car parks which have been built with sheet piles. So in the left picture you see the rusty appearance of the steel. So the architect wanted to keep this specific aesthetical aspect of the steel, so it's rusting, as you can see. But on the other side, at the entrance, You have standard sheet piles that have been coated with a coating which is also quite pleasing, and protecting also the sheet piles from this rusting. So what are the main parameters that you have to take into account, and why are sheet piles cost effective when it comes to underground car parks? Well, the first one, as we already saw, is the execution. It can be executed much faster, up to 2 times, as you'll see, especially when you use this large AZ800 range, so wide piles, which can be driven quickly into the ground. And then the second thing is that it's not only a temporary, but it can also be used as a permanent retaining wall. And furthermore, it can transmit vertical load. So it acts also as bearing piles, so it can reduce the amount of natural resources needed for the bearing capacity. As I already said, nowadays with the pressing equipment, there are no vibrations. The noise is very low, so you can use them also in urban areas, low settlements, and a design life about 50 years and more. I mean, bridge abutments today are designed for 100 years and more, whereas usually a quay wall 35 to 50 years, and underground car parks normally for 50, sometimes 100 years. The other thing which is quite interesting is that it's a displacement pile, so you don't have to remove the soil in order to build a secant pile wall, for instance, with concrete. So you have less spoils, you have less soil to extract, so less transport, less trouble with the neighbors because less traffic. Now, there are 3 different alternatives to build such an underground car park. The first one is when you install the sheet piles as a temporary retaining wall, and then you extract them. So it's good for the circular economy because you can reuse the sheet piles for other jobs. Sometimes the contractor prefers to leave the sheet piles in the ground, which is from an environmental point of view not a good thing, but you don't need to mobilize extracting equipment, so it's a way to do it. But the one that we prefer, and the one that's probably the most cost effective, at least in our opinion, is the one where you don't need these concrete walls inside and use the sheet piles also for the permanent wall, gaining also some valuable space, especially in densely populated areas. We're talking about a few % of the space that can be saved in this way. Another project, just to show you a few pictures on how it can look. So this one is in Belgium, in Aalst, downtown. So this aerial view shows you that the sheet piles have been installed in the middle of the town, close to adjacent structures with foundations. So this is not an issue anymore, like it was in the past. And it's also watertight, because in most of the Netherlands and also in Belgium, you have the water table, which is quite shallow. So you have to also find a solution to keep it watertight. And at the end, seems to be stuck. Okay, yeah, sorry. So another interesting way to do it is this one. So it's in Brussels, where they use the top-down construction method. So this means that you install the sheet piles, you pour the slab, the top slab, and then you start working below, excavating below. That's what should be in the next slide, but okay. And then afterwards, this is how it looks like, so very nice. The advantage is that you can be working above the ground, so for the building, or open the space for the cars. And you can also save some time, so it's a good thing. We're talking about a few weeks up to a few months, which is quite interesting. There was a comparison study that was made by a very renowned consulting engineer in the Netherlands, which we asked them to do, to compare these different alternatives for the Dutch market. And this is the key finding about the cost. We'll see also about the environmental impact. So here we're talking about a difference of at least 40% when comparing steel sheet piles with the alternative methods, being the cutter soil mix or the secant pile walls. And from the environmental point of view, as I already said, we can reuse the sheet piles a couple of times, normally for temporary structures up to 10 times, and then it can be recycled. So usually the carbon footprint is lower than for other solutions. There was a study made by the city of Zurich in 2014 comparing steel sheet pile solutions with alternatives, so concrete, and the result is quite appalling. So the carbon footprint, so CO2 equivalent emissions, are 2 to 4 times higher if you consider concrete compared to steel sheet piles, and this was done by an independent company working for the city of Zurich. We already mentioned EPDs, and this is a good thing because, in fact, if you want to compare the environmental footprint or the environmental impact of different solutions, in our opinion, you should go through a life cycle assessment and compare the solutions with environmental product declaration, which correspond to the product that you're going to use and not with generic databases. That's the best thing to do. And based on this same study by Witteveen and Boers in the Netherlands, life cycle assessment showed that from this point of view, so if you look at the global warming potential, the difference is even quite higher. So rather than the 40%, we're talking about at least 60% and above if you're looking at the global warming potential. Now, what we're also working on is traceability. That's quite important for the facility management, but also if you want to reuse the sheet piles afterwards. So the idea is to be able to know exactly the properties, be it now the technical properties, but also when it was installed and the state of the sheet piles of each element after a few years. So this is something that will also be done with the building information modeling, which will be possible in the future. So if you have a few takeaways from these few minutes, is that if you use sheet piling not only as a temporary but also as a permanent retaining structure, you can gain valuable space inside of your underground car park or basement. So it's always the same. You have an environmental impact which is much lower. In this particular case, it was a little bit more than 60%. Faster execution, also like for the buildings, it's up to 2 times faster to execute the retaining wall. And from the cost point of view, which is a very important key indicator for the investors, of course, we're talking about something from 40 and above % more cost effective. Thank you very much for your attention.
Yeah, thank you, Joao. That was very interesting. Also, especially thank you for the great summary in the end. And it's time again. So if you, as people in the audience, have any questions, please type them in the Q&A field at the bottom of your screen. Meanwhile, I have a question for you, Joao. You were mentioning this study that was performed in the Netherlands and said that alternative solutions would at least be 38% more expensive than using steel sheet pile walls. Well, there was a study for the Netherlands. Is that something that could be transferred as well to a country like Germany or any other country? What is your view on that?
Well, we know, for instance, that in the Netherlands, they use a lot sheet piling because of the high water table. So there are a lot of parameters that have an influence on the costs and on the choice. Now, soil conditions and groundwater, for instance. And what we did is also, we're doing the same analysis for the German market, and we'll do it also probably for other markets. But for the moment, we don't have the results. So the final report, we expect it next year. But we, in the first findings that we have already received, we have seen that it will be more cost effective. Maybe the numbers will change a little bit. It might not be 40% or 50%, but for sure, it will be more efficient. On the other side, concerning the environmental impact, the conclusion should be quite similar because the influence, for instance, of transport over short distances is quite low. So that from that point of view, if you use the same design and the same constraints, then the environmental footprint should be quite similar.
Mm-hmm. Okay, thank you. We have one more question from Sandeep coming. It says, major advantages. Are there any major advantages of U-type over Z-type?
Well, we could talk for hours about this topic. It really depends on the country and the habits. I think if you look at the Netherlands, and Belgium, for instance, it's almost 95% of Z-type piles because they use a different design approach and they penalize the U-types. If you look at Poland, I would say that more than 70% are U-types, and in Germany it's about half-half, a little bit more Z-type. So I would say there are some advantages for U-types for temporary applications, but when it comes to permanent applications, if you do the design according to the latest Eurocodes, Z piles are the preferred choice because you don't have to take into account those reduction factors. But I don't want to go into the details, technical details, but for sure, I would say that for permanent applications, Z types have a big advantage compared to U types.
All right, thanks a lot. That was a clear answer in the end. Good. We don't have any further questions for the time being. So thank you, Joao.
You're welcome.
And I see that in the chat room we have a comment. I would like to read it out, and maybe we can have a feedback from our speakers panel on this comment that I will read out now. It comes from Chisco Ruiz. He says, I see we tend to have a habit of pricing per ton, but in fact, clients have other project relevant concerns, like for example, euro per square meter, linear meter of wall or roof. And he says, I don't see buildings specified on weight of concrete. Is this a comment, Olivier, you would like to give some feedback to?
Yeah, it is a really relevant comment, because as I said in the introduction speech, we need to look at the building as a whole and not at each part independently. So this pricing per ton, it's usually what the steel fabricator are using, but at the end of the day, for me, it's a wrong KPI, because if you only look at the price per ton, you will exclude several solutions which are at the end cheaper because they allow you to save a lot of material. So if you save 30% of the weight of steel in a solution, if this steel is 10% more expensive per ton, at the end, your solution built will be cheaper. It's also the same for the environmental criteria. Some people are comparing material on a per ton based. That's wrong, because you don't need the same amount of material for each of the solution. So what you need to take always as a measurable thing, it's the final cost of the building and not the cost of one specific element, because this specific element can allow a lot of savings on other parts of the building, on other parts of the elements. So what we need to look is the total cost. And when I say cost, it can be euro, it can be environmental cost, it can be energy cost, but total cost of the building, taking into account the technical choice that has been done.
All right. Thank you for your comment, Olivier. On that, we have one more a technical question in the Q&A. I'd like to read it out. It says, is 16MO3 gaining acceptance for fire resistance, ? To be used in commercial buildings? I think there might be a question for Joao. You're on mute.
No, I think this is not for sheet piling. I mean, 16MO3.
Yeah, I think 16MO3 is the code for the what we call fire resistant steel. So it's a steel which is mainly used in Asia, produced by Nippon Steel, which has a decrease of material property, which is slower with the increase of temperature. Globally, this type of steel is not taking off, because at the end of the day, today, we have a lot of other techniques and a way to calculate the fire resistance of commercial building, which is far more cost effective than the use of this steel. So an increase in the steel strength of the steel has more effect today than the use of this type of steel. So fire is always a question when we tackle a steel building. My initial background is fire engineer, so I'm structural fire engineer. So I spent a huge time of my career to work in this calculation of building. I must tell you today there is not anymore any issue with the fire resistance of a steel building. So this can be calculated, technical answer, and many different technical answers are available to build this building in the safest manner possible. So I must remember that steel is not a combustible material. Steel is not burning. Steel is not melting when you have a fire into your building. So don't be afraid by this. They are all the answer and the possibility to make a safe building in steel.
Yeah, thanks a lot, Olivier. I think that answered the question very well. I would like to come now to the closing remarks and to summarize it in a few words. I hope that you could see that steel is efficient in the way that it saves energy, it saves time, it also saves cost. When planning something in steel, it's sustainable in terms of being environmental friendly. You can reuse it, you can recycle it, and it's flexible, last but not least, when it comes down to office walls, to office sizes, for example. There are no pillars needed for long spans, it was pointed out. There are temporary permanent structures possible when using sheet piles, for example. And also being efficient, sustainable, and flexible is key for ArcelorMittal to master the challenges, not only when it comes to construction, but in general when it comes to tackle climate change. And I do not want to close this morning's breakfast session without pointing out at what ArcelorMittal is doing to ensure that climate neutral steel production will become possible in the future. It's our clear goal to reduce CO2 emissions by about 30% until 2030 and to become fully climate neutral in our European operations for 2050. And therefore we have started already very promising, I would say, projects. They are underway to use hydrogen, for example, in addition to coking coal in our blast furnaces in various European locations. Among them are sites in Germany, France, and Spain, and Belgium. And we are also planning a pilot plant in Hamburg at the moment in Germany to fully use hydrogen in the future instead of natural gas. And by doing this, as of 2024, with a production volume of 100,000 tons, we will be the first steelmaker worldwide doing that on such an industrial production level. Well, this is where we stand today, and I invite you to find out more about what we're doing in terms of climate protection. And you can do this and click on our website, the corporate website, the Climate Action Report. You see here on the screen, that's the cover picture of this report. And together with the presentations, which we will send later, we will also send you a link where you can directly find this Climate Action Report. I hope that we could help you understand a bit better this morning what steel as a construction material can do to improve also your business needs and business results. And I thank you for your attendance. Wish you a good day and maybe see you again on a topic for steel. Thanks a lot. The webinar is over now.